Hi everyone and welcome to Smart Alex Coaching. In today's video, we're going to be looking at how to use a factor tree to find the prime factorization of numbers. Prime factorizations are very useful because you can use it to find the highest common factor or the lowest common multiple between a set of numbers. And you'll be learning about that in our other videos. For our first example, we're going to be factorizing the number 360. We begin by writing 360 at the top, and we're going to find two numbers that multiply to give 360. I'm going to choose 36 and 10, so we're going to write it as 36 on one branch and 10 on the other branch. And we're going to repeat this process going down the tree until we get to the prime factors. So for 36, I can break this into 6 times 6, and each of these 6's can be broken down into 2 times 3. And once we get to 2 and 3, we can't go further because these are the prime factors. So I'm going to circle it to indicate that that's going to be the end of my branch. For 10, I can break this into 2 times 5, which are also prime factors. So we can circle it because that's also the end of our branch. So we now have 3 2's, 1, 2, 3. We have 2 3's and 1 5. So we can express 360 as being equal to 2 times 2 times 2 times 3 times 3 times 5, or 2 cubed times 3 squared times 5. And this is the prime factorization for 360. Now, some of you may ask, what if we don't start with 36 times 10? What about if we start off with, say, 90 times 4? Well, the answer is you should still get the same prime factorization for 360 because for every number, it has its own unique prime factorization. So let's give that a go. For 360, I'm going to break it into 90 times 4. So for 90, I can break this into 30 times 3. 30, I can break it into 3 times 10. Now, 3's are prime factors, so I'm going to circle it. For this 10, I can break it into 2 and 5, which are prime factors as well. The number 4 can be broken down into 2 and 2. So everything has now been broken down. And if we double check, it has got 1, 2, 3, 3 2's. It also has 2 3's and of course 1 5. So as you can see, 360 can also be expressed as 2 times 2 times 2 times 3 times 3 times 5, or 2 cubed times 3 squared times 5, which is identical to our first tree. In this next example, we're going to be factorizing 3,780. Again, we begin by writing the number on top, and I'm going to break this down into 378 times 10, mainly because I can see that the number 3,780 ends in a 0. Now, 378 is an even number, so I can break this into 2 times 189. 2 is a prime number, so I'm going to circle that. 189 can be broken down into 9 times 21. 9 can be broken down into 3 times 3, which are prime numbers, so we're going to circle that. 21 can be broken down into 3 times 7, which are prime numbers as well. And 10 can be broken down into 2 times 5, which are prime numbers. We're now going to check how many 2's, 3's, 5's, and 7's there are. There are 2 2's. There are 1, 2, 3, 3 3's. There's 1 5 and 1 7. So to summarize, 3,780 is equal to 2 times 2 times 3 times 3 times 3 times 5 times 7, which is equal to 2 squared times 3 cubed times 5 times 7. And this is the prime factorization for 3,780. Thank you so much for watching this video. In our next videos, we're going to be looking at how to use prime factorization to find the highest common factor and lowest common multiple between a set of numbers. So make sure to subscribe and we'll see you in the next video. Thank you. Bye for now.